In 1952, Union Pacific engineers designed a locomotive that would make Big Boy obsolete, more efficient, more powerful per dollar, better on curves, lower maintenance costs, everything Big Boy wasn't. They built it, tested it, and then quietly killed the entire program. No press releases, no public explanation, just internal memos marked confidential, and a prototype that disappeared into storage, then scrap. For decades, railroad historians didn't even know it existed. This is the story of the locomotive Union Pacific didn't want you to know about, and why the truth threatened everything the railroad had invested in steam power. The Big Boy was never supposed to be the final answer. Union Pacific knew that from the beginning. When the first Big Boys rolled out of Alco's Schenectady Works in 1941, they were already a compromise. Massive articulated steam locomotives designed to haul freight over Sherman Hill without helper engines, is burning coal in an era when oil was becoming cheaper and diesels were proving their worth on passenger runs. But World War II changed everything. Diesel production shifted to military use. Railroads couldn't get new diesels even if they wanted them. Steam was the only option, and Union Pacific needed power. The Big Boys delivered. 25 units built between 1941 and 1944, the largest, most powerful steam locomotives ever operated in North America. They became legends. And that was the problem. By 1945, the war was over. The diesel-electric technology had matured rapidly under military pressure. EMD and Alco were building freight diesels that could match Big Boy's pulling power with multiple units working together, controlled by a single engineer, requiring less maintenance and no water stops. The economics were shifting fast. Union Pacific's management saw it coming. Internal reports from 1946 showed diesel operating costs were 30 to 40% lower than steam on a ton-mile basis. Maintenance hours were half. Crew sizes could be reduced. Yeah, the math was brutal and unavoidable. But Union Pacific had a problem. Big Boy. 25 of them, purchased between 1941 and 1944. Still relatively new. Paid for with wartime capital appropriations, and carrying an enormous psychological weight. These were the machines that had kept freight moving when the nation needed it most. Scrapping them after less than a decade would be admitting a very expensive mistake. So Union Pacific tried something different. What if they could build a steam locomotive that matched diesel economics? But not in fuel costs, that battle was lost, but in maintenance, availability, and operational flexibility. A steam locomotive that didn't require the infrastructure Big Boy demanded. Something that could run longer between shop visits, operate on lighter rail, navigate tighter curves. The project started quietly in 1949. No grand announcements. Just a small engineering team led by Arthur Stoddard, Union Pacific's assistant chief mechanical engineer, working on what internal documents called Project Omega, a high-pressure, oil-fired, triple-expansion steam turbine locomotive. The concept wasn't entirely new. Steam turbines had been tried before. The Pennsylvania Railroad had experimented with them in the 1940s. But those designs were direct drive turbines. The turbine connected mechanically to the driving wheels. Maintenance nightmares. Union Pacific's approach was different. Use the turbine to generate electricity, then drive the wheels with electric motors. A steam-electric locomotive, the best of both worlds, theoretically. The engineering made sense on paper. A high-pressure boiler, 600 psi compared to Big Boy's 300 psi, feeding a compact turbine that could operate at higher thermal efficiency than reciprocating cylinders. The turbine would drive a generator, and the electricity would power traction motors on the axles, giving each wheel independent control like a diesel-electric. No reciprocating mass, no rod wear, no complex valve gear. It's just smooth rotational power converted to electricity. The prototype emerged from Union Pacific's Omaha shops in early 1952, designated as Experimental Unit X-22. It didn't look like Big Boy, smaller, sleeker. The boiler was only 60 feet long compared to Big Boy's 95 feet. Total weight, 520,000 pounds versus Big Boy's 1.2 million. But the turbine produced 4,800 electrical horsepower, enough to match 3/4 of Big Boy's tractive effort in a package that weighed less than half. More importantly, the X-22 could operate on curves and grades that Big Boy couldn't handle without infrastructure upgrades. The articulated frame wasn't as long. The axle loading was lighter. It could navigate the tighter curves of secondary lines and branchwork that Big Boy's massive rigid wheelbase made impossible. Initial tests were promising. X-22 hauled test trains over Sherman Hill in May 1952. Performance met projections. The turbine ran smoothly, steam pressure held steady. The electric traction motors provided precise speed control. The engineers reported better throttle response than conventional steam and smoother acceleration than Big Boy's abrupt power delivery. But the maintenance reports started revealing problems. The high-pressure boiler required specialized water treatment. Any impurities at 600 psi would cause scaling that could lead to catastrophic failure. The turbine blades eroded faster than expected. High-velocity steam at 900 degrees Fahrenheit carried microscopic particles that wore down the metal. Blade replacement intervals were measured in weeks, not months. As the electrical system had issues too, the generator and traction motors were essentially diesel-electric components adapted for steam operation. They worked, but the constant vibration from the turbine created problems diesels didn't face. Brush wear accelerated. Armature bearings needed frequent inspection. The electrical system required specialists, technicians who understood both steam and electrical engineering. Union Pacific didn't have many of those. And then there was the fundamental economic problem that killed the entire concept. Fuel costs didn't matter. Union Pacific's engineers had built X-22 assuming fuel economy would justify the complexity. Oil-fired steam turbines were more thermally efficient than reciprocating steam engines. The numbers looked good, but diesel electrics were even more efficient. And by 1952, the gap between oil and diesel fuel prices had narrowed. The cost advantage Union Pacific hoped for didn't exist. Worse, the X-22's maintenance costs were tracking higher than Big Boy's, not lower. The specialized components, the high-pressure boiler, the turbine blade replacements, everything required expertise and parts that Union Pacific would need to develop from scratch. A Big Boy was expensive to maintain, but at least the railroad's mechanics knew how to maintain it. X-22 was a mystery machine. The test program continued through summer 1952. Union Pacific ran X-22 on freight assignments across Wyoming and Nebraska, gathering data, tweaking systems, trying to solve the maintenance problems. Some issues improved, others didn't. And with every passing month, more diesel-electric units arrived on the property, demonstrating that they could do everything X-22 promised without the complications. In October 1952, Arthur Stoddard submitted his final report to Union Pacific's Executive Committee. The conclusion was careful, technical, and devastating. Unit X-22 demonstrates that steam-electric propulsion is technically feasible but economically non-viable, given current diesel-electric performance and fuel costs. Continued development would require capital investment exceeding the cost of equivalent diesel fleet expansion with uncertain return. Translation: diesels were cheaper and better. Building more steam turbines, even advanced ones, made no sense. The Executive Committee made their decision in November 1952. Project Omega was canceled. The X-22 would be stored pending disposition. No production orders, no further development. The attempt to save steam power with technology had failed. X-22 sat in dead storage at the Cheyenne shops through 1953 and into 1954. Occasionally, mechanical department staff would inspect it, checking for corrosion, documenting its condition. But no one seriously considered putting it back in service. The railroad was buying diesels as fast as manufacturers could deliver them. In 1955, Union Pacific made the decision to scrap X-22. But the official reason: obsolete experimental equipment, no further use. The real reason was simpler. Keeping it around was an embarrassing reminder of money spent trying to save a technology that was already dead. The locomotive was cut up in Cheyenne in early 1956. The turbine was saved briefly for possible museum display, but eventually scrapped when no museum wanted it. The electrical components were salvaged for parts. Everything else went to the melters. Within months, nothing remained except paperwork in Union Pacific's engineering files. And most of it marked confidential. For years, railroad historians didn't know X-22 existed. The prototype had operated for less than a year. No photographs were released to the press. Union Pacific's annual reports never mentioned it. The few engineers who worked on the project moved on to diesel development and didn't talk about their failed steam experiment. The story finally emerged in the 1980s when researchers digging through Union Pacific's archived engineering documents found the Project Omega files, specifications, test reports, maintenance logs, Stoddard's final evaluation, the full technical details of a locomotive that could have been Big Boy's replacement, if economics had worked differently. X-22 represented the last serious attempt by a major American railroad to develop advanced steam technology competitive with diesels. It failed not because the engineering was impossible, but because it didn't matter. Diesels had already won. Not through superior power, X-22 proved steam could match diesel performance, but through economics, as simplicity and operational flexibility that even the most advanced steam technology couldn't overcome. Union Pacific buried the truth not out of malice, but out of pragmatism. Admitting they'd spent substantial capital trying to save steam power when diesels were obviously the future would have raised uncomfortable questions with shareholders and regulators. Better to quietly scrap the experiment and move forward. The irony is that X-22 would have made an excellent museum piece. It's a working example of how close steam technology came to competing with diesels in the 1950s. A demonstration that the end of steam wasn't inevitable from an engineering standpoint. It was an economic decision. But Union Pacific didn't see it that way. They saw an expensive mistake that needed to disappear. And it did. The locomotive that was supposed to replace Big Boy became a footnote, a what-if story that almost no one remembers. Proof that sometimes the best engineering doesn't win. Sometimes economics decides everything. And sometimes the truth gets buried because it's easier than explaining why you were wrong.